Hey there, everybody. This video is going to talk about something brand new, something that you have never heard of before, or if you did hear it, you probably were wondering what that word meant. We are talking about logarithms, or logs, as I say for short. Okay, so logarithms are logs, easier to say, and it's really just another way to write and think about exponents. So here is the relationship between logarithms and the exponential expressions that we've been looking at. Okay, when I have, okay, and it's important to know how to say this. When I have log base b of a, okay, so that's how you say it here. Log base b of a equal to x. That's really telling me that b needs raised to the x power to equal a. So I like to think of logs more as a question, okay? So you can see that here below. When I have log base 2 of 4, and when I'm trying to figure out what that is equal to, I'm really asking myself the question, what power do I need to raise the base of 2 to equal 4, okay? So the log is actually equal to the exponent that you need to raise the base to equal the number that you're taking the log of. And I know that seems really weird and confusing and like why are we making this complicated? Okay? Logs are really powerful, and in the past, like when calculators didn't even exist, logs were used to make calculations of very, very large numbers, and they still have some applications today. So they are important to know about. Even though we have, calculators at our disposal to make very large calculations, they still have purpose and meaning today. Okay, so whenever you see a log, you're really asking a question. Okay, think about it like that. So what we do a lot of the time is we convert logs to exponential form and we convert exponentials to logs. So we need to be able to go back and forth. That's going to help us down the road when we run into some trickier types of exponential equations. Okay, so if I have log base 3 of 9 equal to 2, remember logs are really just asking what power do I need to raise 3 to equal 9? Well, I need to raise 3 to the second power to equal 9. So the trick here is start at your base and you're going to loop around. Okay, 3 to the second power equals 9. So that loop helps you remember the order that the numbers go in. So same thing here, log base 7 of 1 equals 0. So we're asking ourselves, what power does 7 need raised to equal 1? Well, 7 needs raised to the 0 power to equal 1. So we start at our base, 7 to the 0 power is equal to 1. So it's just a nice little trick to help you remember the order that you go in when you're doing this conversion. It also works when we're going the opposite way. Okay, if I want to convert an exponential to a log, I start at my base and I loop around the same way. Except this time, right, it's going to be a log, so we're going to have to actually write the word log base 14 of 196 is equal to 2. So again, ask yourself the question to make sure it makes sense. What power does 14 need raised to equal 196? It needs raised to the second power. So logs are always equal to the exponent. And another one here. So again, we can use our little trick here. Log base 12 of 12 is equal to 1. So again, we're asking ourselves, what power does 12 need raised to equal 12? Well, it just needs raised to the first power. So I know it seems strange now, but I promise you this is going to come in handy when we get to really complicated and challenging exponential equations down the road. So a lot of the times what we do with logs is we evaluate them. Okay, when you evaluate something, you are finding its value. You're finding what it's equal to, right? So log base 7 of 49 is equal to the exponent that we need to raise 7 to equal 49. So if it helps to think of this kind of as like a question, then do it. Okay, what power does 7 need raised to equal 49? Oh, it needs raised to the second power. So this log base 7 of 49 is equal to 2. That's what it means to evaluate a log. You're finding its value. You're calculating it. Now, you might be confused about the second one here because there is no base written. Okay, this is actually something that comes up a lot. It comes up so often, actually, that we call it a common log. So anytime you just see log, it is really log base 10. And again, the name for that you'll hear is a common logarithm. Okay? So if you don't see the base, just put a 10 in there and you can keep going. So we're thinking, what power do I need to raise 10 to equal 100? Well, I need to raise 10 to the second power to equal 100. So this one's equal to 2 as well. Now, sometimes you're not going to be able to mentally evaluate or mentally calculate what a log is equal to. And that is when the change of base formula comes in handy, okay? So a great example is what I have down here, right? I don't know what power I need to raise 16 to equal 64. I don't have a clue, right? This is where the change of base formula comes in handy. The change of base formula says if I have log base b of a, I can split that into log of a. Okay, remember, if there's no base, it's just base 10. By log base 10 of b. And the reason we're using log base 10 here is because you have a log button built into your calculator. It just says log. That is already log base 10. So we're going to use that because, you know, the functionality is already there. It's easy to use. It's built into our calculator. It's going to reduce the amount of work we have to do. So the change of base formula can be used for this example down here. Since I don't know what power 16 is raised to, I'm going to use my change of base formula to figure it out. Okay? So I am going to do log base 10. I'm not going to write the base 10. Okay? So log base 10 of 64 divided by log base 10 of 16. If I do this in my calculator, it is going to tell me what power I need to raise 16 to equal 64. So when we punch that in, it gives us 1.5, which tells me 16 to the 1.5 power is equal to 64. Okay? That would have been challenging to do mentally. Okay? I didn't know how to do it. That's when your change of base formula is useful. All right, that is it for this video, a little introduction on logarithms. Let me know if you have any questions, and have a great rest of your day.